All right. Well, I'm going to kick us off because I've got a little bit of an intro before I hand things over to Luke, and that'll give any other folks joining just another minute or two to get in before the good stuff. Because no one came here just to hear from me. But welcome everybody. My name is Jeff Martins. I am a member of the Determinate Systems team. I'm going to be your host for the webinar today. Today's webinar is going to be all about Determinate Nix. This is our distribution of Nix that is focused on performance, security, and user experience in enterprise environments. So real quick before we jump into that, a little bit about Determinate Systems if you're new to us. We exist to make Nix more simple, secure, and confident in enterprise environments. We build a whole bunch of tools. I'm sure just about everybody knows about the Determinate Nix installer, which is the best way to install Nix across a variety of different system types. And that's not just us saying that. That's what a lot of the folks are sharing in their recommendations for how to get started with Nix. We also are the company behind FlakeHub, which is a secure hosted binary cache for Nix. And we create Determinate Nix, which is going to be the focus of today's webinar. We also love to contribute upstream to the Nix project, but across the Nix ecosystem. We are lucky to count two longtime Nix contributors and the founder of Nix as part of our team. So Ilko Dolstra is one of our co-founders and the creator of Nix, along with Graham Christensen, the other co-founder, one of the most prolific Nix contributors and minds over the last 10 or so years. But most importantly, though, we help organizations like the ones you're part of harness the full power of Nix, whether that's for software development, infrastructure management, or secure and reproducible builds. Leading today's section is Luke Perkins, one of my colleagues and fellow Portlander, even though he is frequently all over the world. If you've been around the Nix community for a while, you've probably come across Luke's work and writing, whether that's blog posts, talks at conferences, or contributions to the ecosystem. He brings a deep technical expertise, but also has a strong focus on developer experience and a really great knack for making complex topics understandable. So I really appreciated having the chance to work with Luke and learn from him. He's one of the developers on our team. He's contributed across Nix, Flake Hub, and all of our products. And he's going to talk a little bit about the latest enhancements, features, and capabilities in Determinate Nix. So before I hand it over to him to do that, just a couple housekeeping notes. We will do a Q&A at the end of this. You are free to put your questions in anytime during the webinar. You don't have to wait till the end, but I will wait till the end to take questions. I believe the Q&A feature is enabled. If not, someone can let me know in the chat. So use the Q&A feature. So to ask your questions, if you do it in chat, that's also fine. And then we are recording this webinar, so I can send it out to you afterwards. You can share it with your colleagues, and we will be sharing it out to others afterwards that weren't able to make it today. So with that, I'm going to hand things over to Luke to dive into today's topic. So Luke, go ahead and take it away.
All right. Hello, everyone. Jeff, thanks once again for a great intro. Welcome to our fourth webinar, Inside Determinate Nix, the best way to Nix at work. My name is Luke Perkins, and I'm coming at you from my home city of Portland, Oregon, USA this time. Sadly, not the best city in the world, like Buenos Aires, Argentina, as the last few times, but also not too shabby. I chose Determinate Nix as the topic this time around because thus far our webinars have been either very high level, as in the best practices for Nix at work webinar, or they've been specific to Flake Hub, which is which, as Jeff said, is our platform for working with Nix Flakes. So it feels like a very natural time to focus on what we're doing with Nix itself. And as you'll see, I'd say we've been very busy with that. So what is Determinate Nix? Determinate Nix is what we at Determinate Systems call a downstream distribution of Nix. And what we mean by that is that Determinate Nix is a separate project from upstream Nix, and it has its own development process, its own center of gravity, its own set of priorities. At all times, we base Determinate Nix on a very recent upstream version. In most cases, the latest upstream, but sometimes there's a little bit of a lag there. And we try to sync those two on our side as often as we feasibly can. We call it a downstream distribution because our goal is to eventually upstream all of the improvements we make that would be meaningful for the Nix community at large. So there are a fair number of things in our distribution that are specific to our platform that are not particularly meaningful to broader to Nix users more broadly, especially ones who aren't interested in Determinate. And we, of course, don't intend to foist anything unwelcome onto them in the upstream project. If you'd like to keep tabs on Determinate Nix, our repo for it is public, and you can find it on GitHub in the Determinate System / Nix SRC repo. In addition to Nix itself, Determinate Nix also includes a tool called Determinate Nix D, which we'll see in action in a few minutes here. Determinate Nix D is a kind of sidecar CLI tool that lives alongside Nix and performs a bunch of tasks that it doesn't really make a lot of sense for Nix itself to perform. So to give some examples, Determinate NixD performs some important interactions with FlakeHub, our platform for Nix Flakes. You can check on your current authentication status with FlakeHub by running Determinate NixD status, and you can log into FlakeHub by running Determinate NixD login. And you can also do things like file bug reports to Determinate systems using this Determinate NixD bug command. There's some other really fun stuff in Determinate Nix that you'll see a little bit later on. And of course, it wouldn't really make much sense for Nix itself to perform any of these platform-specific actions. So when we talk about Determinate Nix, we're talking about these two things: our Nix distribution, downstream distribution, and Determinate NixD. And they're, of course, built to work as a cohesive unit. So why are we building Determinate Nix? Where does it fit in with our broader goals as a company? And why not just work on the upstream project? Well, first, we strive to provide as streamlined an installation process for Nix as we possibly can. And this installation story is basically how we began our life as a company a couple of years ago. So a few years ago, we built something called Determinate Nix installer as an alternative to the official installer. So our installer is a battle-tested CLI written in Rust and designed for and tested in a wide range of environments, while the official installer is honestly basically just a bash script that hasn't really meaningfully changed in about half a decade. We also provide a graphical installer for macOS for folks who just want to point and click. Nothing wrong with pointing and clicking if it works. And finally, we also support installation by mobile device management. So if you're interested in having Nix automatically provisioned to developer workstations on large teams, this is a great option to consider. And having our own distribution is really nice for streamlining installation because it means that we can do things like provide a default Nix configuration that works well with our own distribution of Nix, and we can make that an integral part of the installation process. So while you can use Determinate Nix installer to install upstream Nix, and many people do use it that way, thousands and thousands, the other installation methods are tailored to Determinate Nix specifically and to the platform and the overall end-to-end experience that we're building. So this segues us nicely into the next item, which is opinionation. Now, learning and using Nix can be quite daunting for people because first of all, like the core concepts can be quite challenging. Derivations and the Nix store and store paths and evaluation and realization and all this stuff. So the core concepts by themselves can be quite challenging, but it's also daunting because Nix is such a multifaceted tool and people use it in wildly different ways. There are different usage patterns, different idioms, and many people who are extremely curious about Nix get hung up on this or that challenging aspect of Nix, and sometimes they quit because it's just too much to take in, and they ultimately stick with what they already know. So maybe that's Homebrew or ASDF or Docker or something along those lines, and we're trying to build something that keeps those people in the fold. And so one of the things that we offer in Determinate Nix is actually fewer choices. So when you install Determinate Nix, Nix is ready to use, and we actively discourage and deprecate some ways of using Nix, as we'll see in a minute here. And with opinionation comes lower cognitive load. So you install this thing that's meant to just work, and it actively dissuades you from doing things that we, in our decades of cumulative experience, think that you shouldn't do. And this kind of opinionation would be quite unwelcome, and rightfully so, in the upstream Nix project. Another reason we're doing Determinate Nix is because we built an end-to-end experience of using Nix that we want to work as a seamless whole. In the last two webinars, I talked about Flake Hub, and Determinate Nix is built to work seamlessly with Flake Hub to the point where you should be able to be up and going with features like Flake Hub Cache and private flakes in a matter of minutes. And having our own distribution has really unlocked this kind of platform story for us. Another major factor is release cadence. So upstream Nix, like any major open source project with thousands of users, takes its time in making decisions. It operates on a pretty conservative, consensus-driven basis, and it typically takes weeks to cut a new release. Now, this isn't criticism at all. It's just the reality of open source, and it's one that we kind of fundamentally accept. But our incentives are different. We frequently need to ship important changes to unblock users, and being on someone else's schedule just kind of doesn't cut it. With our own distribution of Nix, we can release without waiting on a quorum of maintainers, working in different time zones and with highly variable levels of availability. And because we can ship on our own schedule, this enables us to sort of establish and work within a tight feedback loop where users tell us they're seeing installation failures or unexpected behavior or some kind of minor regressions, and we can provide turnaround time to the tune of hours rather than weeks. And I'll say a little bit more about how we do this in a minute. While this webinar is focused on developers, I do think it's important to note that we built Determinate Nix because we wanted to see Nix in the enterprise. And like it or not, you can't get Nix in the enterprise if the higher ups, the people who make the decisions and sign the checks, can't adopt it. And so we put in the work, and it's a lot of work to become SOC 2 Type 2 compliant. And we provide service level agreements for both Determinate Nix and Flake Hub. And unsurprisingly, if we didn't have our own distribution of Nix that we had full control over, it's not really clear how we would be able to provide that. So we have our own distribution, but how do we make this all happen? Now, first, as I mentioned before, we have a separate repo on GitHub at Determinate System/Nix SRC. Feel free to file issues there or clone it and play around with it just like you would with any other OSS project. Especially feel free to play around with any with features that are currently active in pull requests and things like that. We're always open to feedback in that form. On a more concrete level, we have an automated release process that ensures that anytime we update Determinate Nix, the changes propagate throughout all of our repos and dependencies in a controlled fashion. So the way this goes is that at some point, we decide that it's time to cut a release, and we push a tag to the Nix SRC repo. That kicks off an automated process that cuts a new release for everything else. So if we push a tag for, say, now this version doesn't exist, but say for version 3.8.1, we get automated 3.8.1 releases of our Determinate Nix action for GitHub Actions. We get a 3.8.1 release of Determinate Nix and Determinate Nixd, push to install.determinate systems, our artifact server, and so on. To give a juicy little technical detail, we actually manage all of this using a really powerful durable execution and orchestration engine called Temporal, which I strongly encourage you to check out if you're I think as a technological enthusiast, it's one of my favorite things. So I do encourage you to look at that. So once the release process is finished, one final change is made in our artifact server at install.determinate.systems, and the new latest version is made discoverable to Determinate Nixd. So when you run Determinate Nixd version, you discovered that you're no longer on latest. You run an upgrade command, and within a few seconds, you should be good to go. This tightly orchestrated release process is important to us because we distribute Determinate Nix in a lot of different ways. So first of all, like I said, all executables need to be fetchable via our artifact server. NixOS users need to be able to install it from our NixOS module by running NixOS rebuild. People using Determinate Nix on AWS need to have fresh AMIs available. And people using Determinate Nix via USB stick or fun stuff like that also need to have it available. Now, we're still refining this process, but we have it down to about 2 hours, and we have some ideas about how to improve our responsiveness to user needs even further. Now that you know what Determinate Nix is and why we're doing it, let's get into the real fun stuff and talk about features that currently set it apart from upstream Nix. I'll start small. So we've been making a number of small but consequential ergonomic improvements to make Nix more intuitive. An example I really like is renaming the Nix profile install command to Nix profile add. This change makes a lot of sense because there's a Nix profile remove command, and Nix profile install doesn't really make much sense as the antonym of remove as a verb. We saw complaints about this inconsistency in user forms for years, and we decided to just change it, and we hope that upstream follows suit. And so this is one of the fun things you can do when you have your own distribution. Relatedly, we've been working a lot on improving error messages and logging. I'll give a quick demo of this. Okay, so there's this one really opaque error message that nobody likes. And so I have this flake.nix right here, but as you see, it's not yet committed to Git. Now, if you do an operation like Nix flake show on an older version of upstream Nix, you get this error. So you get path unknown / flake.nix does not exist. I don't know what that means. I don't know what to do with it. There's nothing actionable in it. And now with Determinate Nix, when you run this, when you run Nix flake show, you say path flake.nix in the current repository is not tracked by Git. To make it visible to Nix, run, and it gives you this, copy pastable command right here. And I do this, and now I run Nix flake show, and it does what is expected of me with no error. There's like 12 to 15 examples of this that we've added recently. That's just one, but this is the kind of work that we're doing. Yeah, so that's an error message and logging improvement that we're really excited about. Another distinguishing feature of Determinate Nix is that flakes are considered stable. It's something that we just went and did. You don't need to enable flakes in your configuration or via CLI flags. They're in there. They work out of the box. You can't disable them even if you want to, and they're getting better all the time. Correspondingly, Nix channels are deprecated in Determinate Nix. So we think that channels are quite simply not the right way to use Nix because they violate reproducibility, and we feel that channels have been fully superseded by flakes as an idiomatic way to use Nix. So to give an example, if you run Nix channel commands like Nix channel add or Nix channel list, you'll see a big unmistakable warning telling you that channels are deprecated. Eventually, the Nix channel CLI will be not just deprecated, but removed altogether. So make sure to plan accordingly if you're a Determinate Nix user. So when I talked about opinionation before, stable flakes and deprecated channels is really like that's really kind of the foremost example of something that I suspect you would notice first and foremost when you switch to using Determinate Nix. Sometimes less really is more. But I think we on the team would all agree that the most consequential feature currently in Determinate Nix is lazy trees. This is something that's been worked on by Elko Dolstra, creator of Nix and co-founder of Determinate Systems for several years, and we're really, really amped that it's finally landed in a Determinate Nix. So what are lazy trees? Well, in a nutshell, without lazy trees, Nix is really aggressive about copying files from the current directory into the Nix store. So aggressive that every time you evaluate something inside the current flake, Nix copies the entire current directory into the Nix store, or rather, previous Nix. If that sounds excessive, well, that's because it is. It turns out that there is a way of being much smarter about this. With lazy trees, on the other hand, Nix is much more parsimonious about copying files into the Nix store, and it does so only when it absolutely needs to. That is, it copies files lazily into the Nix store. And this provides a major speed up to some operations, often a speed up of 200 or 300%, and occasionally even more. I've seen like 5x improvements in some cases. Lazy trees generally makes the biggest difference when you're working inside and making frequent changes to a large repository. And when I say large repository, this very much includes large monorepos. To be quite frank, without lazy trees, flakes can be essentially unusably slow in large monorepos, given how much file copying needs to do. But we're confident that lazy trees will unblock Nix for developers working in monorepos, and we think that's really exciting. Lazy trees are still under developer preview in the most recent Determinate Nix, but there are two ways to activate it. First, you can add lazy trees equals true to your custom Nix configuration at /etc/nix /nix.custom.conf, and that will activate lazy trees for all operations. Or you can activate lazy trees on a per command basis by adding the lazy trees flag, which I'll show you in just a minute. But don't just take my word for it. I'm going to cut to a demo, and then I'm going to show you some data. Let's go back to my terminal here. Now, I'm going to show you first an example. I'm going to evaluate the Cowsay package, which it's like some of you have seen. It's like the say package, but it's like a cow doing it. It's pretty funny. We use this in a lot of our examples. I'm going to evaluate this package with, as you see right here, no lazy trees selected for this specific operation. So let's see how long this takes. Definitely feels slow. Definitely doesn't feel awesome. And we're looking at a total elapsed time of something like 15 seconds, which is not great. Well, if we want to enable lazy trees for this operation, we can switch over this flag to set lazy trees true. I have lazy trees in my configuration. I don't really need to do this, but oh, look at that. 3.1 seconds total. So the exact same operation, just in the same repo under the exact same conditions, yields something like a 4.5x speed up, which is pretty awesome. So I created, if you go to the determinate system /lazy trees comparisons repo on GitHub, you can see this in the GitHub Actions runs. So you see that I created this this information table, this comparison table right here. And I basically I basically like evaluate a bunch of packages in Nix packages, so all in the same machine, like all in the same repo, the same everything across the board. And I calculate a speed up. So this it's running this calculation using a thing called Hyperfine, and it's doing this at least 10 times in all cases. And you see a speed up in some cases, more modest, 1.75x. In some cases more substantial, like you see 3.16x, etc. Like I said, somewhere around 2 to 3x speed up is something that you can expect in a lot of cases. So yeah, that's pretty exciting stuff. Okay, another great feature we've added to Determinate Nix is automatic hash fixes. If you've worked with Nix for any amount of time, you've run into the problem where you need to specify a hash for some set of vendor dependencies, or when fetching a GitHub repo or something along those lines. But something changes in the inputs, and you run a command like nix build, and Nix tells you that the hash is incorrect. And now the onus is on you to fix it manually. So you need to copy the correct hash, like paste it into the correct place. I've gone through this thousands of times as a Nix user, and I'll be honest, it's not torture, but it's also something that I really wouldn't mind automating out of existence if I can. Well, with Determinate Nix, we've done precisely that. With Determinate Nixd, you now have this Determinate Nixd fix hashes function that does all of this for you and simply automates the problem away. Once again, don't just take my word for it. Let's go over and check it out. I'm going to go to this hash mismatch demo repo really quick. So I'm building this really simple Go server. You see right here, it's just has a ping endpoint, returns JSON saying message Pong, and I'm building it with this flake. Oops, actually, let me reset something really quick and Git. Oops, yeah. So you see right here. Oops, so you see flake.nix, and you see right here I have this vendor hash for my for my Go module dependencies right here. Now, if I try to build this package right here, I run nix build. It says, you specified this hash, but actually the correct hash is this one. Now, ordinarily in Nix, I would take this, I would manually copy it. I would go over into this vendor hash thing. I would swap that out, and it'd be good to go. Well, now I can do something totally different. So Determinate Nixd has this fix hashes command, and I can select auto apply, and I do this, and it just works. So it says flake.nix on line 18 changed old hash, old bad incorrect hash, to new good correct hash. And so when I run nix build, you see that actually, I can, just to verify, I'm going to remove the result. I'm going to run Nix build all over again, and it just works. And I run result bin hash mismatch demo, and my Go server starts up as normal. Really, really fun stuff. Okay, going back to the presentation here. So I've talked a bit about the past and the present, and now I get to tease some fun bits from the future of Determinate Nix. One feature that I'm really excited about is parallel evaluation. Now, what parallel evaluation boils down to is that the Nix evaluator for expressions that you write in the Nix language has historically been single-threaded, which means that Nix has generally underutilized CPU in some of its most important everyday tasks. And this has become a larger and larger bottleneck over time as repos like Nix packages have grown and people have started using Nix for much bigger and badder things than they did once upon a time. Now, parallel evaluation, of course, means orchestrating evaluation across multiple threads instead of just one. In some internal tests, we've seen speedups of a factor of 3 or 4 for many operations. And what I love about parallel evaluation is that it's exactly like lazy trees in the sense that it makes Nix better without making any demands of the user whatsoever. There's nothing new to learn. There's nothing to change in your code. You just do your work and things are magically faster. And as with lazy trees, you probably wouldn't even notice it unless it were taken away from you. And another nice thing about it is that you can introduce it, is that on the code base side, on our side, we can introduce it incrementally over time on a per evaluation type basis, which is what we plan to do as we gather feedback over time. A great example of an operation that is readily parallelizable is Nix flake check, which runs all the checks outputs that you specify in a flake. Now, currently, Nix runs these checks in a single-threaded way, which is not optimal. Making this operation parallel, though, is likely to speed things up considerably, especially in CI runs on larger projects. And there are dozens of operations in Nix that are eligible for parallelization in this way. Now, we announced that we were working on parallel eval in a blog post a while back, and I encourage you to have a look at that. It provides some lovely technical details and some nice diagrams and some real like nitty gritty from Elko Dostra that go well beyond the sort of very high level picture that I've painted here. Another upcoming feature that I'm really excited about is native Linux builds on Mac OS. So one of the basic limitations of Nix is that by default it builds only for the current system. And so if you're on a team that mixes and matches Mac OS and Linux stuff across Mac OS and Linux users, making the Linux stuff available and usable on Mac OS can be a challenge. A classic example of this would be Docker or OCI images. They need to be built for Linux, but you often want them to be available to the Mac OS folks on your team and buildable in Nix. Not just pushed up to a registry or something. Now, there are some options available for this, including remote builders or building Linux things in CI and pulling them from FlakeHub cache. But we're introducing a new option, which is the ability to build Linux things with Nix on Mac OS by delegating that work to Mac OS's built-in and recently added virtualization framework. So that means no QEMU, or I think it's pronounced QEMU. I always forget. Whatever it's called. There's no QEMU. It's just Nix making calls to Swift code under the hood. So imagine being on Mac OS, installing Determinate Nix, and then immediately being able to build Linux packages using a command like this without any setup or configuration and without having to set up remote builders. As a full-time Mac OS user myself, this is really exciting stuff, and we're super eager to get this out to our users. If this all sounds like a compelling proposition to you, it's really easy to get started. If you don't currently have Determinate Nix or Upstream Nix installed, go to docs.determinate.systems for instructions on Mac OS, Linux, including WSL and NixOS. If you're currently on Upstream Nix and you'd like to migrate over to Determinate Nix, check out our migration guide at docs.determinatesystems/migration. And finally, if you're already on Determinate Nix, you can check if you're running if you're currently on latest by running Determinate Nixd version. If not, the command will tell you to run sudo Determinate Nixd upgrade, and you should be ready to go in just a few seconds. That's it for today, everyone. Thank you so much for your time and attention. We're super excited about Determinate Nix, and we hope you are as well. We hope to see you all very soon, and I look forward to your questions and comments in the Q&A.